Humanity as a species is a very odd type of primate. Not only are we incredibly intelligent with a clear ability to manipulate our environment to suit our needs, we're also the only species of primate capable of comfortably and extensively walking bipedally. In fact, we're so good at walking bipedally, we can't really walk quadrupedally anymore with any sense of comfort. There are very few cases where humanity walks quadrupedally for any extended period of time, but that's not the only way that primates can move. A lot of primates are capable of climbing trees using their arms and legs to propel themselves. Most great apes walk quadrupedally on their knuckles and are capable of walking bipedally for at least short periods of time, and monkeys are capable of swinging through the trees. And because a group of scientists began to look at an ancient species of ape called Lufengpithecus, we are now beginning to piece together the story of how apes walked upright. Welcome back to Paleopedia, and Lufengpithecus is a species of hominid from East Asia during the late Miocene epoch, around 10 to 5 million years ago. Around the size of a modern-day chimpanzee, Lufengpithecus primarily fed on fruits and is known from thousands of dental fossils and a few skulls, which is very important. A team of researchers led by Terry Harrison from New York University looked at some of these skulls that were discovered in the 1980s in China's Yunnan province. Now, unfortunately, the skulls are pretty damaged due to time, and previous studies have revealed that the semicircular canal in the inner ear of these skulls were not very well preserved. Now, why is that important? Well, the semicircular ear canal is how we maintain our balance when we walk around upright. Since we don't have a tail to balance ourselves, it's incredibly important. The size and shape of the semicircular ear canal correlates to how mammals, including apes and humans, move throughout their environment. So to get a more accurate look at Lufengpithecus' inner ear, the team took a bunch of CT scans to rebuild and recreate the semicircular ear canal of this species. The team then compared these scans to living and fossil apes, including humans from Africa, Europe, and Asia. The analysis shows that early apes shared a locomotor repertoire that was ancestral to human bipedalism, and the inner ear provides an evolutionary look at the history of ape locomotion. Comparing all of these inner ears to each other, the team believes that bipedalism in humanity's evolution evolved in 3 steps. Apes first moved through the trees similarly to how gibbons move through the trees today. And as the ape evolution progressed, the last common ancestor of both apes and humans used a combination of locomotions, from climbing, clambering, walking on the ground on all fours, and moving through the trees using just their arms. And it was from this mix of locomotion that bipedalism eventually became dominant in human evolution. It's possible that once our evolutionary lineage got more comfortable walking bipedally, fine motor skills related to the inner ear, like balance, were able to be refined over time. It's important to note, though, that even though humanity evolved bipedalism throughout our evolutionary history, we only did that because of an odd group of apes that began to move about their environment much more variably than before. So we're the odd species when it comes to great apes. As a species that's in the middle of an evolutionary change, Lufengpithecus is an incredibly important species for us to study. Not only does this species help us understand our evolution, it also helps scientists understand how ape diversity changed throughout history. The research team believes that external factors such as climate change also played a role in how apes and their method of movement evolved. Around 3 million years ago, as the planet cooled, ice sheets began to form in the northern hemisphere, and this corresponds with an uptick in the complexity of the bony inner ear. More research is needed to be done to determine exactly why walking upright helped our ancestors as the ice sheets began to grow, alongside why ape diversity began to decline at the same time. While there is still so much we don't understand surrounding not just human evolution, but ape evolution in general, this new information helps us get one step closer to understanding it all.